Good evening, everyone. It's my pleasure to introduce Sandeep Mahajana sir, a highly esteemed faculty member at Sambhavam IAS. Sir hails from Karnataka and holds a master's degree in international relations from Sark University, where he was a gold medalist among participants from 8 countries. Since 2013, Sir has been imparting his extensive knowledge, starting his teaching career at Byju's. Sir areas of expertise include geography, environment, and international relations. We are fortunate to have him guide us on our path to success. I would like to start the class with a positive quote by APJ Abdul Kalam. Climbing to the top demands strength, whether it is to the top of Mount Everest or to the top of your career. This motivational quote by Dr. APJ Abdul Kalam reminds us that reaching the pinnacle of our ambition, such as succeeding in the UPSC exam, requires immense strength and determination. It is a journey filled with challenges that test our resolve. As we begin this session with Sandeep Mahajan sir, let's channel our inner strength and remain committed to our goals. With his expert guidance, we are well equipped to overcome obstacles and reach the heights of our aspirations. With this, I would request sir to please proceed with the class. Thank you and over to you, sir.
Thank you. Hi all, good evening. So, yes, uh, let us quickly begin with the session. Okay. So, today we'll start with climatology. Okay. The first session is on climatology. Yes, whenever you sit with geography, I want you people to ensure that you have atlas with you. Okay, you should have atlas, and any book you're writing, like however it is, ensure it's a plain book so that it helps you in many other aspects. I would say, like 1/4 of the book at least you leave to write updated issues, current affairs, or if you read NCRTs. Okay, this you should always leave. Okay, so don't make running notes, guys. This is not what do you call it as a history or a polity where you need to make some running comments. This is a technical subject, purely technical subject, where understanding the concept is very important. I will give you notes. I will dictate the points I want you to write. That you can. Second thing, I think you people have a group. I'll be slow and I'll tell the points. Uh, please avoid asking for repetition because we will be dictating notes without seeing any material. So, like, we won't be able to recollect the exact lines. You can ask your friends once the session is done. Second, after explaining any particular topic, I will give you some 2 to 3 minutes. Whatever doubts you have with respect to that particular topic, you can always ask us. Okay. So given all this, with respect to climatology, after the topic is completed, I will also tell you from which book you need to read that particular topic for that day. Almost for next 2 to 3 weeks, continuously I'll take classes so that a significant portion of geography is done for you. Right? So first, with respect to climatology, we need to discuss some basic concepts. Okay, some basic concepts. So normally we use the terms like hot and cold. This is very simple, but it looks very confusing in geographies. Why? You see, now 20 degrees Celsius. 20 degrees Celsius. Okay. Is it hot or cold? 20 degrees Celsius. Is it hot or cold? Cold. Normal, moderate. Moderate. Do you know recently UK Germany people told that 24 degrees Celsius is said to be heat waves for them. Okay. Germany, France people told 24 degrees Celsius is heat wave. That means they were very, much troubled with that. Okay. Now you tell 10 degrees Celsius. Now comparing 20 degree with 10 degree. Okay. Compare 20 degree with 10 degree. What is 20 degree now? What is 20 degree now? With respect to 10 degree. With respect to 10 degree. What is 20 degree? It's hot. Correct? It's hot. 20 degrees hot compared to 10 degree. Now you take 30 degree. 30 degrees Celsius. So compared to 30 degree, what is 20 degree? Compared to 30 degree, what is 20 degree? Cold. So can I say we cannot come to conclusion of whether 20 degrees hot or cold? It depends upon surrounding temperature. Is it clear, guys? So tomorrow, if I say, there is a warm. You see here, I'll have a wind, guys, okay? Here snow is there. Here snow is there. And when you look at it like this, snow is minus 10 degrees Celsius. The wind which is coming down is 5 degrees Celsius. Okay. Snow is minus 10 degrees Celsius. Wind which is coming down is 5 degrees Celsius. Can we say the wind is hot compared to minus 10 degrees Celsius? So now do you understand this concept? Do you understand this concept? Hot and cold. So hot and cold is always with respect to surrounding water or air temperature. Okay. This is the first point. Second, how does temperature increase? That means, what is the reason for temperature to increase? You see, guys. One, I have a box. Okay. Now, in this box, I'll heat it. Okay. So now you people tell me, When I heat from outside, when I heat from outside, will the temperature increase, guys? Okay. So whenever we heat from outside, that is external heat is provided. External heat is provided. Temperature increases. Okay. Second. You see now, in this box, I have only few air particles. Okay, I have only few air particles. Now what I'll do, I'll add more air particles. So guys, you tell me, if we add more air particles into this box, air particles are coming closer. Do you agree? Air particles are coming closer. So you tell me, guys, if air particles come closer, if in a classroom, in a small room, if I put more people, will temperature increase or will temperature decrease? Temperature increases. So can you tell me the difference between the first and the second? The difference between first and second, in both cases, temperature is increasing. Correct, guys? In both the cases, temperature is increasing. But in first case, it is due to external heat. You're giving external heat. Second one is not due to external heat. Second one, let me use rather than, yeah, internal heat, but not external heat. So whenever it is not due to external heat, it is called as adiabatic heating. Do you all understand the term adiabatic heating? Adiabatic heating means we are not providing heat from outside. Okay. So if we are not providing heat from outside, it is called as adiabatic heating. Please understand, I'm not using the term pressure. I'll come to pressure. Okay. So please see, no need, ma'am. I'll dictate notes. I'm just trying to say, if you heat air from outside, temperature increases. That is when you say that externally heat is provided, or you're not heating at all. You're bringing all the particles towards each other. When you bring all the particles closer, what is going to happen? Heat is going to increase. So that is called as adiabatic heating. Okay, this is called as adiabatic heating. So what is adiabatic heating? Externally, if heat is not provided, okay, remember this terminology. For me, exam is all about language. Okay, externally, when heat is not provided, and if temperature increases, then it is called as adiabatic heating. Now I want you people to tell me, think and tell this, guys. When in one box, You have more number of air particles. In another box, you have less number. A and B. Okay, A and B. So can you tell me, when we talk about A and B, uh, which one will have high temperature? Which one will have low temperature? See guys, A will have high temperature, B will have low temperature. Correct? Okay. Now you tell, where will you have high pressure? Where will you have high pressure? High temperature will be there. High pressure is also there. Low temperature is there. Low pressure is also there. Can you tell, where do you have high density of particles? Where do you have more density of particles? High density, low density. Okay, guys. So the basic point here is, when particles come closer, okay, when particles come closer, due to friction, due to many aspects, temperature increases. If particles are moving far away from each other, temperature reduces. Temperature pressure decreases, temperature pressure increases. Okay, these two process is known as adiabatic heating and cooling. This is called as what? Adiabatic heating and cooling. Okay. See, in any area, if you have more air particles, then I say density is high. If density is high, temperature is high. If temperature is high, pressure is also high. But if you have less air particles, imagine in a bus, less number of people are there. If there are less number of people, less pressure, low density. Imagine in a bus, I'll put lot of people. If I put more people, okay, then there will be lot of pressure and lot of temperature. Okay, so this is the basic point. Can you write down this? You write climatology. Climatology. Below that, you write basic concepts. Basic concepts. Hyphen. Below that, you write temperature and pressure. Temperature and pressure. Below that, you write Suma, yes. So you write, below that you write temperature. Temperature. Hyphen. It is a degree of, it is a degree of hotness or coldness. It is a degree of hotness or coldness of a body. Hotness or coldness of a body. Full stop. Hotness and coldness, hotness and coldness depends upon surrounding temperature. Surrounding temperature. Example, you write these three as 30, 20, 10. 30, 20, 10. You write three boxes and write these. So below that you write 20 degrees Celsius, 20 degrees Celsius is cooler compared to 30 degrees Celsius. 20 degrees Celsius is cooler compared to 30 degrees Celsius. And 20 degrees Celsius, 20 degrees Celsius is hotter compared to 10 degrees Celsius. 10 degrees Celsius. Next, you write temperature increases due to, temperature increases due to, first one external heat. That is when we heat an object, from outside, when we heat an object from outside, then temperature increases. Next point. Within within the air particles, within the air particles, when they come closer, when they come closer, temperature increases. Temperature increases. Even when, even when external heat is not provided. External heat is not provided. This is known as this is known as adiabatic heating. Adiabatic heating. Draw these two, guys. Draw these two. Alaka Jyoti Panda. That I'll explain in geography what will happen. That is not correct. Actually, we try to consider land and air in the statement that you have given. That is with respect to land and air. That's not correct. But basically, in atmosphere, only atmosphere, if we consider, when air particles come closer, temperature increases. When air particles move out, temperature doesn't. Piyush, just remember, adiabatic basically means when all the particles come closer, right? Pressure increases, temperature also increases. Guys, just imagine in a small room of 50 people capacity, if I put 100 people, if I pump 100 people, there will be lot of pressure among the people and temperature increases. That's the reason I'm teaching you this, because just imagine all of a sudden if I use adiabatic heating, cooling without understanding. Yeah. So Anjali, what you didn't understand, ma'am? You said you are not understanding anything. What is the problem? Please don't come to class late. Once you miss the topics, you don't understand what we are talking about. Geography is way too technical for some. Okay. Done with this, guys. Did you draw? Okay. Yeah. Now, you write below. Heading, you write. Heading, you write. Adiabatic heating and cooling. Adiabatic heating and cooling. Adiabatic heating and cooling. Raj, directly proposed. Hyphen. Whenever there is, whenever there is high density of high density of air particles, air particles, then then pressure and temperature increases. pressure and temperature increases. When density of particles reduces, when density of particles reduces, temperature and pressure, temperature and pressure also decreases, also decreases. So guys, I want you to remember, there is no need for you, but telling you, there is something called PV is equal to RT. P is pressure, V is volume, R is constant, T is temperature. Okay. So if we keep volume and R constant, P is directly proportional to temperature. Okay. So write these two ways. No, don't worry. Please don't worry on all this. I just gave you. Just I want you to remember, guys, if there are more air particles in a place, I'm repeating again and again for those who didn't understand. If there are more air particles in a place, then temperature increases, pressure increases. If there are less number of particles, temperature decreases, pressure decreases. Okay. So this is the basic concept. Draw these two. Done. Done. Yes. Now I'll ask you something. Look and tell. Okay. This is Earth's surface. This is Earth's surface. You have more air particles closer to the Earth. You'll have less air particles away from the Earth. Okay. Just now you tell me this particular thing. A and B. A and B. Can you tell me which layer will have high temperature, high pressure? Which layer will have low temperature, low pressure? A will have high temperature, B will have low temperature. Very good. Now, this is the concept we are going to see in other areas as well. Okay. This concept I am going to teach you in other areas as well. Okay. Now, you see, guys, let me tell you, listen for a while. This is a story which is not proven, and we also don't know what occurred. Okay. So don't worry about all those things. For 5 minutes, listen to this properly and understand. Now, some 4.5 billion years ago, okay, 4.5 billion years ago, entire universe, entire universe was together, guys. Okay, entire universe was together. So the meaning of this is, when everything is brought together, when everything is brought together, so when all the particles are brought together, you will have infinite temperature. Okay, you will have infinite temperature and you will have infinite pressure. Okay, see, when all the particles come together, you will have infinite temperature and you will have infinite pressure. And suddenly, one fine day, one fine day, there was an explosion. Okay, this explosion was called as Big Bang. Big Bang. Now, when universe got exploded, guys, you had lot of splits. Okay, so guys, you tell me, when it exploded, when it exploded, it started expanding. It started expanding. It's just a minute, guys. I don't know why you people are unnecessarily texting so many things. I told you very clearly, understand this concept. You are still stuck in the last concept. You don't understand this concept. Again, when I teach next topic, you will be talking about these concepts, right? So you will lose the track. See, I'll tell you, there will be very few people who will clear this exam. Okay, there will be very few people who will clear this exam. And if you want to be one among them, understand what's going on. Don't be stuck in the past. If you really get doubt, if you really get doubt, make a note of it. Keep it. I'll give you time. You can ask. But don't keep on texting unnecessarily because you will lose everything. I can just stop chat and keep teaching and going. I won't feel any disturbance. But what I'm trying to say is you are unnecessarily diverting focus of others also. And you only won't get an opportunity to ask. Fine. I think these are your first classes. You should have some things, some concept before half an hour, and some people in future, they will be asking 2 3 days sessions back. Suddenly they'll come and ask, sir, I didn't understand high temperature, high pressure. We are going in order. If you don't understand, again, videos will be provided to you, right? See them. And then you ask. Sometimes some clarity won't be there. And two things I'm telling you. If you are understanding what I'm trying to say enough, don't bring your knowledge here. I'm not talking about Pangea, Panthalassa. I'm not talking about anything. Please don't put your knowledge here. Okay. So everyone, I'm talking from the basics, guys. I know that this is technical subject. You might have heard of some terms. So don't put all those words. If you know these concepts beforehand, you're free to leave, right? But don't disturb others. Clear? So everyone, see here. Once there is explosion, once there is explosion, entire universe started expanding. See this, as universe is expanding, what is going to happen? Particles are moving away. Particles are moving away. So if particles are moving away, that means it is cooling. Yes. So this was asked in the exam. What is it? Immediately after explosion, universe started expanding and cooling. So the statement is correct. If they give you universe started contracting, that means universe started coming together. and temperature started increasing, then the statement is wrong. Okay, so immediately after Big Bang explosion, particles started moving away. There was cooling of the universe. And guys, there was two things, guys. In the universe. There were two things. There was some solid particles. There were some solid particles called as planetesimals. Okay, there were some solid particles called as planetesimals. There were some gases. Okay, there were some gases called as nebula. There were planetesimals. There were nebula. Okay, so guys, this is very, very important for us. What is it? Initially, as soon as the universe exploded, you got some particles of different sizes. You also had some gases. These sized particles were called as planetesimals, and the gas was known as nebula. And what happened initially? As particles were moving away, universe started cooling. Okay, universe started cooling. I want you to write heading as evolution of Earth. Evolution of Earth and atmosphere. Evolution of Earth and atmosphere. Below this, you draw this. You draw these two. Just remember, this is a story. We really don't know whether it happened or not. Done? Okay. Then guys, you see here, guys, when something is exploded, okay, when something is broken, everything will not be of same size. If I take a coconut and if I hit it hard, I will not get pieces of same size. Okay, so Explanation I'll give, ma'am. Just draw diagram. I'll give you in a proper manner explanation. You see, guys, when something is broken, it got split into different particles. Now, what happened? These particles were attracted by larger particles. Okay, so larger particles absorb smaller particles. Everyone, you tell me now. Uh, when all the particles come closer, when all the particles come closer, will the temperature increase or will it decrease? When all the particles come closer, temperature increases. Very good. As temperature increases, guys, it is said that temperature increased to such an extent that it got converted into liquid magma. Got converted into liquid magma. Okay, so the entire earth became molten magma. Earth became liquid magma. Fine. And at the same time, earth was rotating. They say planets were formed like this and earth was rotating. Just a minute, guys. Forget these things. Now what happened? All the particles came closer, and when all the particles came closer, temperature increased and all the solids started becoming into liquid. And around this liquid, there was some particles. Around this liquid, there was some particles which were gases. These gases were known as primordial atmosphere. Yeah, Piyush, it was not because of collision alone. When all came together, like, temperature increased and it became liquid. So guys, the gases which were there around is known as primordial atmosphere. And in this atmosphere, hydrogen and helium were present. Okay. In this atmosphere, hydrogen and helium were present. Please understand, prelims question. In the primordial atmosphere, huge quantities of oxygen was present. Wrong. Oxygen was not there. Only hydrogen and helium was there. Okay, guys, even today in the sun, if you take, like, you will have hydrogen and helium. If you talk about Jupiter, if you talk about Saturn, in many planets, hydrogen and helium is more because they were the primordial atmosphere. I will explain much more, guys. I will explain in detail. Let's go slowly because, like, one day only you won't get all the points. This is technical. Fine. So draw these two. Draw these two. Write these two. Just a minute, guys.